I'd like to thank CPI Trade for putting on this event and for the opportunity to speak here today. I hope that by the end of my presentation, you'll all have a better understanding of what an asset information model is, why an asset information model is needed, some of the challenges that you could face actually providing one, and a simpler way of doing it. So I'm Cliff, I'm the Senior BIM Manager for PACE. We're based in Kuwait. We're a multidisciplinary team. I'd like to share with you today some real experiences that I gained on a project that I was working on in 2015 in the UK. Now, one of the objectives from the client was to have an asset information model. Now, back then, BIM was quite new, let alone an asset information model, which is actually the output of the BIM model. So the project included some laboratories. It was for a university, so we knew that MEP was going to be of utmost importance, so that FM teams would know where things were, how to adjust the settings. So let's start off with what is an information model. So an asset information model, as you can see, this is the industry definition. It's data and information that relates to assets to a level required to support an organization's asset management system. So in other words, what it is the information that the FM teams need to keep the building up and running. So why do we need an asset information model? Well, traditionally, O&M manuals are paper-based, and it takes a long time to get this information into the FM systems. So what the asset information model can do, because it's structured data, is it can help to transfer this information automatically into the FM systems so that the buildings can be up and running sooner and more effectively. Now, these FM systems, you'd be surprised, a lot of people don't really understand what an FM system is, and I was one of them. People think that the FM system is just one system, but it's actually a number of different systems are used by the FM teams. Just like the design teams and the construction teams all use different systems to design and construct the building, it's no different for FM. So if you're in the FM team and you're interested in the users, you'll have FM systems that are looking after things like room bookings, desk bookings, equipment bookings, attendance, car park, all these different things, door key logs. If you're more interested in the looking after the building itself, you're going to be primarily concerned with the planned preventative maintenance systems. Now, what these systems can do is they can schedule events to make sure that components are tested, for example, fire dampers and things like that, or sensors. Not everything goes into the PPM system. You wouldn't put a door in there, for example, because it doesn't need PPM. Other users will be more interested in building management systems or water treatment, for example. This would be another system because you'd be testing the water systems for Legionella or for chlorine levels. Then there are cleaning, fire protection, security, energy management, and O&M document systems. Now, the last one on the list there is probably the most important because that has all the information in it that feeds all the rest of these systems. Or you might be more interested or looking after the finance of the building, so you might be using SAP or Oracle and these FM systems. So collectively, when someone says we need to put this information into an FM system, this is what an FM system looks like. So we need to start off with a set of asset information requirements. Now, this is the list of the data that's actually needed, the data that is required to actually run the building. Without a set of asset information requirements, teams tend to put everything in the building. They tend to put everything in about every single asset, and some assets could have hundreds of parameters. So if you consider a federated BIM model, for this example, has 300,000 objects, Some of them will come from structure, and some of them will come from the architect, the building fabric. But a lot of them, the ones that are important for maintaining the building, will come from the MEP systems. And then we have the other architectural components such as windows and doors and things. But out of these 300,000, we only really need to know about 10,000 of them for running the building. And of those 10,000, each component could have, hundreds of parameters, but you may only need about a dozen. Then we also have the O&M system, which has got about 90,000 objects. So out of 300,000, we only really need to be focusing on 10,000 and possibly 100,000. So as you can imagine, there's also further complexity in delivering an asset information model when you consider the project delivery teams. This is an example of the information management roles in a project and how they relate to one another. And where you can see at the bottom, IA, that's an information author. On a project, there could be dozens of those. So we have a situation where we have different teams working on different packages. They're producing different levels of information at different work stages. They're often working on different networks, and there's a change of domain. When you go from the design phase to the construction phase, all this information needs to be moved from the design team to the contractor, if it's not already on there. And then again, it needs to be moved again onto the FM teams. So there's further complexity in trying to gather all this information together, where a lot of the teams, and this is just a fraction of the software that's actually involved in delivering a project. Companies like Autodesk and Bentley have got hundreds of software applications themselves, so this is just a fraction. So if you're not working in the same building and you're not one company, which you often won't be, you need to keep this information coordinated. So to coordinate the information, you need to share it frequently. So every time it's shared, there is a risk of data loss. You can, of course, write integrations between, for example, Revit and Maximo, but then you need to maintain that, and you need to do that for each instance. So along came COBE. Now, COBE stands for Constructions to Operations Building Information Exchange, and it came out of the United States Army Corps of Engineers. The reason that they came up with it was to have this schema, this data set, which could automatically transfer information into the FM systems. So now we have COBE, we have a common exchange format, which helped a little bit, but actually is still actually very complicated to achieve, because you can't have thousands of COBE files for an FM system. You have to have one, because all of the tabs are all interlinked with one another. So this is an example of a COBE sheet. I'm sure a lot of you have seen it before, but each team will be responsible for uploading their data using these COBE sheets, and these COBE sheets have got about 20 tabs, and you can't just complete everything in one go. You need to do it progressively as the project goes along. And then these files need to be combined into one file. So as you can see, that this isn't really human readable. This was designed for machines to read, and not humans. So I think one of the reasons that COBE isn't being gathered is because of the way that it looks. It's not very user-friendly. So once we realized that this was going to be difficult to achieve on this project, we started looking for another solution, another way of defining the information that's needed, another way of gathering the information that's needed, testing the information so that you make sure it's the information you need. We called in a team of specialists. We called in Active Plan. And this is basically one space where all of the information can be gathered across all of the teams. What it is, it's one space that can gather all the information produced and can present it in a way that can be understood. So we even have an image of the building. We have the key data for the building on the right-hand side. You have a summary, the number of floors, the number of rooms, the number of assets in those rooms. So it's very useful. So the architect would start off the process after the information requirements have been defined. Let me just go back one slide. So defining the requirements, there's no getting away from it. Someone's going to have to go through this and log on to this website or sit down with somebody else and define all of the assets that you need to know about, so which are the ones that need to be maintained. And then you need to then decide what is it you need to know about each of those assets. Otherwise, you might get way too much information. So these web-based services can help to define the requirements. You simply log on, select the components that are likely to be in each space, and then say what you need about each of those components and at what stage you need that information. So at the beginning of the project, you'd have a model, and you could export that to a COBie file, upload it to the system, and now you have a 2D web display of the information. This hasn't been drawn. This is just the information displayed, the XYZ coordinates, and it can include the performance of each room as well. So there's no software needed for this, no AutoCAD or Revit or Tekla or any other software platforms. So you can then click onto a room and see what's in each space. It can also be viewed in 3 dimensions as well. So when teams upload their information, it's actually validated against what was asked for. So we asked for this, and did we get this, or did we get less or more? So again, this saves somebody sitting somewhere gathering all these COBie sheets together and trying to do this. Okay, and then it's a database, so this information can be displayed in different ways. You can have product data templates, so product data sheets. And at the end of the project, so everybody would have logged in and uploaded their information that they need. It will be tested and validated against what was asked for. And then it can be exported to a single COBie file. And this COBie file can then be used to transfer the information into the FM systems. If you don't know what the FM systems are at the beginning, it doesn't matter, because this is an exchange format. So as long as the FM system can take a COBie file, you can just use this. So in summary, information required from the AIM will come from the entire team. And it'll start at the beginning, so we need to define what is needed right at the beginning. Otherwise, teams will waste time providing stuff that's not needed. It needs to be created then, gathered, tested, and aggregated, and this is a very complicated process. It's better to have one space where everybody can log in, even without any software, with a list of requirements that they need to meet. They can upload their information, and then it can be exported to one single file and used to populate the FM systems. So this is just another way of doing it, and it will remove a lot of the complexity. So thank you very much for your time.